today's video, we are going to create a experiment 3 for this project. So as we can see, we already created a new project. So we are going to open our MCC to set up our IC. So click this icon. It's still loading. And now we will click save. So we will click it again since it didn't load. Again, click save. So yes. So there it is. So now we will set up our pin manager. So this is the pin manager. So this is the package we use, the PT40. So this is the pin out and its corresponding pin input and output pins. So now we are going to set up in the pin manager RE7A as output. So this means that our output is in pin 13. So now we only set up uh, this pin only for output. We will proceed to the pin module. In pin module, we should uncheck the analog and the weak pull up or WPU. So we will rename our GPIO as D5 LED. D5 underscore LED. There. So now we will proceed to the system module. So for the setup of the oscillator, we will set is in high frequency internal oscillator with 4 megahertz internal clock and a clock divider value of 4. And we will make sure that our low voltage programming enable is checked. So for the uh, timer 0, since we were dealing with that, we should proceed uh, to its available resources, I guess. Let's see. Oh, there. So we will click this green sign to add that there are 0 here. So we will add a new peripheral. So we are already enabled it. So we will check the enabling timer and we will set our prescaler to 1/256, which is here. So this is our prescaler. And now for the clock source, we should select FO frequency oscillator over 4 as we can see. So now in the period box, we will type or we will put 250 milliseconds. So as we can see, the actual period is uh 249.856 milliseconds. Uh, that is the actual period, or since we already approximate it to 250 milliseconds in the period box. So now uh, everything is set. So now we can uh, ma- generate this code. So to recap, we will set the prescaler to 1 is to 256, postscaler is 1 to 1, the timer mode is 8-bit, the clock source is FOC over 4, and the timer period is 250 milliseconds, and the enabled synchronization is checked, and the timer interrupt is unchecked. So now we could click the generate button to generate this MCC code. So now it is being generated. We can proceed to our main.c. For the timer 0, or for this experiment, as we can see, it is a very simple code. So uh, it only detects if the timer has overflowed. So if the timer is overflowed, it means that the LED will toggle and the timer will reset again to 0. And this loop goes on and on and on. So this is the code for that, and we will compile this code and program it to the chip, like we did on programming our previous experiments. Our IC is already programmed, so as we can see, the VDD is connected to positive 5 volts, the black wire connected to VSS to the ground, and the orange wire, which is pin 13, to the output. As we can see, if we run, if the program is being uploaded to the IC, the output blinks the LED in a fraction of seconds of delay. So this is how the timer 0 works, and we will try to modify it later with the 2-second uh, delay interval. On delay for this project, we will add the delay ms double underscore delay underscore ms, and we will set it to 2000, since 1 second is equal to 2000 1000 milliseconds. And now we will build this project again, and we will program it with our IC. The same connections applied with the earlier version of the code. In this demonstration, we will add the delay of 2 seconds, or the blinking interval of the LED of 2 seconds. As we can see, the LED blinks slower because it has a 2-second interval, while earlier we did not declare how many milliseconds or seconds does the toggle of the LED will produce. A new project, which is the version 2 of the experiment tree. which is using timer ze- which is timer 0 using interrupt. So uh, the setup for the pin module and the system module are the same to the previous version, which is the timer 0 using polling, but this time we will set up the timer 0 using interrupt. So first we will go to peripherals. Let's see. Or uh, to be to have a shortcut, we we will go to available resources. So it becomes larger. So and search for timer 0. So as we can see, it's here. Then click this green add button. So now the timer 0 peripheral is added. So click the enable timer. It's already. And the clock source should be the same. FOSC over 4. That is the instruction clock. And the prescaler are the same as earlier, which is 1 over 2. 1 is to 256. And the timer period is 250 milliseconds. And enable timer and enable, but this time we will enable the timer interrupt, or we will check the timer interrupt box in the interrupt module. So we will click here in the system. As we can see, uh by default the pin module IOCI is not checked and the timer 0 is enabled or checked. So we will set this by default. So we will generate this code. So it will we will retain this part as is. So we will click the generate button to generate the MCC file. So now as we can see, the code is already the MCC is already generated. So we will go to projects, source files, and the main.c. Uh, for this part, we will modify the two.c files, which is mainly the main.c and the tmr0.c. On this main.c, we should enable the global and the peripheral interrupts for this part of the experiment. So as we can see, they are being commented. We will remove the two slashes to enable those uh, code. So now both of the codes are enabled. We will proceed to the tmr0.c, which can mainly be found in the MCC generated files folder. We already added the modifications. So the first thing you do is to include the header file of the MCC, which is the mcc.h, by typing sharp sign or hashtag include, then quotation marks MCC. Inside those quotation marks are mcc.h. to declare or include mcc.h or the header file of the MCC in reading this program. So to handle or to work our timer zero in using interrupt, we will find this portion of the code, which is tmr0 underscore isr. As we can see, there is a section where we can create a custom code. We will click enter under it and put that our toggle for for our output or the LED. So this is the thing that we need for modification of the code. So we will try to build it now. As we can see, the build is already completed and successful, and it is ready uh, to load to load it on our IC. As we can see, the the pin configurations are the same, and the output of the LED are the same as earlier in the part 1 of the experiment. This means that the part 2 the part 2 and part 1 functions the same. It means that they uh, they produce the same function. However, uh, when in when in coding them, they differ since in the first part we use the main.c, while on the second part we use two files to create the same output. To create a toggle with 2-second interval. So to do that, we will add again the delay ms 2000 for a 2-second delay. So we will build it again and load it uh, to MPLAB IPE to program our IC again. This is the version 2 of experiment 3 with 2-second delay. As we can see, uh, the LED blinks with an interval of 2 seconds. It's also the same as the version 1 or the uh, code of the part 1. As I said earlier, the only difference is that in part 1, we only use the main.c file uh, to use the timer 0, while on the second part, we use two files, which is the main.c and the timer 0 C file or the tmr0.c.